Hi, welcome. In this video, we will learn merge sort asked by companies like Amazon, Microsoft, Facebook, Uber, and Google. Hey, hello everyone. So today we are going to learn merge sort. So far we have seen two algorithms, sorting algorithm, selection sort, and bubble sort, and still we are learning for a new sorting algorithm that is merge sort. Yes. So the thing is, on the point of interview, okay, sorting algorithms and searching. Sorting and searching is the most asked topic in the interviews. If you are planning for any company that is of below or even more than 5 LPA, right? 3 LPA, 5 LPA, 10 LPA companies, okay, 12 LPA companies, you might get questions on sorting algorithms. That's for sure. Because maybe that is the easiest topic, right? Maybe that here we can plan different set of questions. Yes. So there is a high possibility that here we can come up with lots of questions, right? And that's why this is the most common asked questions, most common topic. So in bubble sort and selection sort, we have the time complexity of big of n square. Now we will try to optimize this time complexity with new sorting algorithm that is merge sort, right? Come with a better version of this big O of n square. Okay. So we will look into merge sort today and we will understand the complete things. Basically, we will understand what is the intuition behind it, like we saw of selection sort and bubble sort. Then we will find out what is basically the merge sort is, how it works. Okay, we will understand the working and then we will understand the pseudocode. Okay, how it works. Okay, what is the pseudocode, and then we will do the dry run of the pseudocode. Okay, so we will learn all these four in detail. So it will going to be a fun with a bit of long video, but still I want you to understand this completely, because in many interviews you can be asked merge sort, can ask to create completely from scratch, or there can be some problems that are totally solved by using merge sort. Okay, and then you need to apply it from scratch only. Okay, so let's understand what is the intuition of merge sort. So let's create an array. So I have this an array, and in this array let's take some random elements. So let's take 8 5, let's take some common elements, 8 5 8, and we have then 9, then 0, then 4, then 2. So this is my array, right? So how basically merge sort is, and what is the intuition, how we come to merge sort. Basically, if you can remember that we have solved one problem of merging, right? Merge two sorting algorithm, and understand it like this. Suppose you have one element that is 8. Okay, so if I say that can you sort this element, right? So you will say like, hey, this is only single element, this is already sorted, right? If I talk about 9, right, is this is sorted? Yes, this is also a single element, this is already sorted, right? Now when we have two elements or two arrays, right, take consider this as an array 1, array 2, right? When you have two sorted arrays, and now you need to create a new array by merging it, and that should be sorted, right? The new merge array should also be sorted. So the time complexity, or the time that you will take, it won't be big of n square, right? Basically, because this is sorted, right? This is sorted. What you will do, you will check what is the which is the lowest element, right? 8 or 9. 8 is the lowest, so it will come first and then 9. Right now, this part is sorted, right? Suppose you have one parallel same part like this. We have one 8 and we have then suppose 5 and 2, and let's make it sorted. That is 2 5. So now you have this part is also sorted, and you are asked to that you need to create new array. Basic, you need to merge it, and that should be sorted. And both are sorted. Like this part is sorted and this part is sorted. So again, you won't take big of n square time to sort this. You won't do, basically you will simply add the all the elements and then you will sort it. What you will do, you will check, okay, which is the first element that is smallest. So here 8 and 2, 2 is the smallest. You will take 2 and then you will move it here, right? Then you will compare 5 and 8. So 5 is the smallest, right? And then this array is already sorted. So without an doubt, you will simply put all the elements here, right? So basically the intuition is that when we have two sorted things, already sorted, right? First one and second sorted. We don't take too much time to sort it, right? We can use our common sense, or basically by pointers, we can simply sort them, right? The same principle will apply here, right? We will create very small set of arrays, and then we will sort that small sort set of arrays, and then we will eventually sort the complete array. So I hope you got the intuition, basically what I am talking about. Okay, and now let's see how this will work. So basically merge sort is work in this principle, that is merge. Okay, and not first merge, first is divide, right? So we will first divide, and after this divide we merge it, right? This is the basic things that we are going to do during this complete merge sort video, right? So now let's understand from a very top view, right, from 1,000 feet of view, that how basically what is the principle behind how things work here in merge sort. So basically, as the name suggests, we will divide and merge it, right? So first let's divide it. Okay, now so here we have how many elements? We have 7 elements, right? So if I'm going to divide it, can be either 4, divide will be 4 elements here and then 3 elements here, or I can divide it 3 elements then 4 elements, right? So it's totally up to you, right? You can either go with this path, 4 elements with 3 elements, or 3 elements with 4 elements. But remember, whichever part you are taking, if you are taking first part with 4 elements, then second part is third, you need to do it same again and again. Why? Because if there is something that I'm going to do again and again, that should be same, so that I can use some iterations, I can use some recursion principles, right? So here, that's not a disclosure of recursion, but yeah, we will try to make it same so that we won't create a new long code, right? So what I will do, I will first divide them, right? So if I simply divide this my array into two parts, right? So first part will be of 4 elements. So suppose this is my 4 elements, and second part will be of 3 elements. So this will be of 0, 4 to 3 elements, right? So now my array is divided into two parts. Okay, and that is not a complete divide, right? We are not going to divide it, right? We are going to hypothetically divide. Basically, that means, right, that is not an actual array that you have divided, right? You are just taking consideration that all the elements that are starting from 8 and that are ending at 9, you are just taking into this, you are just looking into this, you don't know about this one, right? Even still it is present, right? Even other elements are present, but you are taking a consideration of these 4 elements at the first. Okay, now we will do again divide and merge, right? So I will further divide it. Okay, and I will first do left one then right one. If you can remember the binary tree videos, right, we have done the same. So I will, if I do divide it, now this is of 4, so if I divide it, it will be of 2 and 2. So first 2, and if I divide this one, so it will also of 2. Okay, so this is I have divided, right? After this, again what I will do, I will divide it further. So I will first solve for the left one, right? And if I divided, it will be single elements, right? 8 and 5. So if I divided, it will be 8. If I divide this one, it will be 5. Okay, right? So this is the element. Same after this, right? Now what I will do, I will divide this one as well, right? But before let's dividing this one, right, we will do the same, right? Let's see here. So now again, as I have discussed earlier, that we have single elements, and now single elements, right? Single elements of the array are itself sorted. So can I say my these elements are sorted, right? My single elements are itself sorted, right? So what I will do, I won't go on further divide, right? I won't go on further divide. I will divide till I am not getting the sorted elements, right? Remember, till I am not getting the sorted elements. Here I am getting the single elements that are itself sorted. So what I will do, I will stop it here, and then what I will do, I will return them. So basically what I will do, I will return these elements, but when I will return them, I will return in a sorted way after sorting. So I will sort them and I will return it, right? So if I return it, it will be 5 and this will be 8. So let me remove it, or let's take the same thing, right? So that we can come up with some new better, or let me create an array. So I will use this array, right? So let me create a small portion of it, right? This one. And what I will do, I will simply say when I will return it, right? This will be my return of it, and I will return it. Okay, I will return 5 and 8. I will basically return the sorted part. So let me put it here. I will return 5 and 8. Let me shrink the size of it. Yes. Okay, then I will return this part as well, right? So this part is done, right? We have returned the sorted part. So again, what I will do, I will come to here and I will again, right? This is not sorted yet, right? So I will further break it down. And I will break it down. It will be 8, single 8, and it will be 9. Okay, now, right, we have single elements, so these are itself sorted, right? So when I will return in sorting form, right? I will return in a sorted way. So what I will do, I will return the two elements in a sorted way. So I will return it here, and that will be 8 and 9. Right? Now this part is sorted, right? This part is also sorted, right? 5 and 8 sorted and 8 and 9 sorted. So when I will return, I will sort them, right? I will sort these two. I will merge them and sort them, right? So basically, I will return the four elements that is again sorted. Don't worry about it, right? How we will merge it, sort it, right? That's the thing. We will discuss about it completely. But see, I'm getting sorted thing, I'm getting two sorted array, and when I'm returning, I am simply returning in the sorted way, right? So I will return with 5, then 8, then 8, 9, right? Now can you see, right? The left part is your sorted, right? So from here to here, right? We have sorted the elements, right? Okay, similarly, we will do with this one, right? Again, this is not basically divided, right? This is not sorted. So what I will do, I will first break it. So I will first break it, and again we have used 4 plus 3. So I will use here 2 plus 1, right? So divide into this form. Now here I have reached a single element that is itself sorted. So what I will do, I will divide this one, right? So I will divide this one, right? If I'm dividing it, it will be 0 only, right? And if I divide this one, it will be 4 only. Okay. So if I'm dividing it 0 and 4, that is again single elements. That means itself sorted. So when I will return it, I will return in the sorted form. So I will return them in the sorted form, right? So I will return 0 comma 4, right? Now 2 is sorted and this array is also sorted, right? So both the arrays are sorted. When I will return it, I will return them in the sorted form. So I will return them in the sorted form 0, 4, 2. So now 0 and 4 will be 0, 2, 4. So now you can see this array is itself sorted and this array is itself sorted. So I will return in the sorted form. And how I will return it? So I will return this complete array, right? And this will be 0, 2, 4, right? This part will come first, 0, 2, 4, and then 5, 8, 8, 9. Okay, don't worry about like how I am merging it how I am merging it. This merge part we will discuss it. I have solved one problems. If you have not checked out, check that video that was completely on the merge part. How I am simply merging the two sorted arrays, right? So basically, this is how your merge sort works. Okay. Again, very clear, right? Very clear basically how we are doing it. Okay. So we have covered basically how merge sort works, and this is the top view of it. We will break it down. We will break it down further till we are not getting single elements, because single elements are alone sorted. And once we are getting sorted elements, right? Two sorted elements, we are merging it. We are merging it and returning it, right? We are merging it and returning it. Okay, so that this is how we are going to do it. And now let's talk about how this merge will happen, right? Because you have a doubt basically how we are merging it. Okay, so let's see, let's try to solve it. So let me tell you here one thing, right? Suppose this is my array and let's take two part. Okay, so let me copy this one. Okay, not this one, this one, right? Because we have few parts sorted and few parts not. So about this one and this one, and let me tell you how basically we'll come to this array by merging it. Okay, then you will get a complete idea. So see, you have one 5, 8, 8, 9. This part is sorted, right? And then you have 0, 2 and 4. Okay, and now what I need to do, I need to merge them in a sorted way. So what I will do, I will check, right? Both the arrays are sorted, right? Both the arrays are sorted. So instead of simply merging it and sorting it, I can use a very good technique, right? I will take one pointer here, right? Suppose I pointer here, and I will take one j pointer here, and I will take one k pointer here. Okay, right? This is the array that I have created. Okay, and I will return it. So I will check which is lesser. Ith point element is lesser, or jth point is element lesser. Jth point. So what I will do, I will fill with the jth element, and I will move ahead. Right? Because these are sorted, I will again compare, is the I between I and ith element and jth element which is smaller. Jth element is smaller. So I will simply put j and I will move ahead. Right? Again, I will compare between ith element and jth element. Right? So jth element is smaller. I will simply put j and I will move ahead. Right? And now j is reached to the its limit. So I will check I is only the left alone. I will simply put all the elements of A, and this is how basically sorted. And I will move my k pointer, right? I forgot to move k pointer, but k pointer will also move in the same way, right? And see, in the last you will have the sorted arrays. Right? Even suppose if the elements are arranged in a different fashion, like suppose here we have 8 5 and 8 9, right? Let's take this example, and this is 5 8 and 8 9. So this is also merged in the same way. Let me take an example where you can guess how basically this will work. So let's see. So basically suppose you have one element here, then here you have 3, then 5, then 7, and here you have 2 4 and 6 and 10, or 6 and suppose 7. Okay, let's see how basically this works. Again, you will take I pointer and j pointer, and you have this and an array of this size, complete size. What you will do, you will take which is smaller, I and j, right? One pointer here, k, I and j, which is smaller, ith element is smaller. You will put one, and you will move your I pointer, you will move your k pointer. Again, you will compare jth element and k, ith element which is smaller, jth element is smaller. So you will put jth, and you will move your k pointer, you will move your j pointer. Again, you will compare I and j, which is smaller, ith element is smaller. You will simply first put ith element, move your I pointer, move your k pointer. Again, you will compare jth and ith, which is smaller, jth element is smaller. You will put jth element, you will move your j pointer, you will move your k pointer. Then again, you will compare ith and jth, you will put 5, you will move your I pointer, and you will move your k pointer. Then we have jth is smaller, I will put j pointer will move, and k pointer. Now both elements are equal, right? I can put either I and j. Suppose I will put I, right? And I will move my k pointer. Okay, this should not be 2 4 6 7. Sorry, my bad. This should be the last. But see, suppose now the single element is left in j. What I will do, I will simply add j here, right? So there will be some spaces in my array, and I will simply put j, and that will be the last. So basically, this is how we will do the merge sorting, right? Basically, when the only idea is when we have this sorted array, right? And this is also sorted. So why we need to simply create like why we need to merge them and then sort it? We can use their sorting behavior. We can use the sorting behavior, and that the pointers technique that I'm using, that can be done only by sorting. So that's why we are doing it. Okay. So yeah, this is the total science behind merge sort. Okay. And you got the idea basically how we are doing it and how all these things working. Okay. Now let's see a pseudo code how I can write this basically. Okay. So now see basically what I am doing. I am dividing it. I am again further dividing. I am again further dividing. Okay. And so basically dividing behavior is same, right? Basically I am dividing in the 4 parts and 3 parts, then again dividing into the dividing from mid. Okay, so basically how I am dividing, here I am dividing from mid. Okay, then again I am dividing from mid, again I am dividing from mid, again I am dividing from mid. Similarly I am merging it, then again I am merging the sorted arrays, again I am merging the sorted arrays. So are you thinking that when we are solving a problem, if you know the my recursion concepts, right? When basically what is recursion, when you have a big problem, okay, and if you can write that problem into the smaller version of itself, that is what recursion is. So right, whatever the work we have need to done, I am simply break it down and I am doing the same work. Whatever the work I have need to done here, I am simply breaking down and doing the same work. So yes, we can apply recursion here, and we will apply. So let's see what will the code of it. So what will be the code? Basically, I will have a function, but before that, let me tell you basically how we will use this array. So again, let's see what were the elements. We have 8, 5, 8, 9042. So 9042. Okay. And let me write the indexes 0, 1, 2, 3, 4, 5, 6. Right. So if you can remember basically, and that if I am calling any function, right, if there is any function, right, and inside I am passing an array, right, I am passing n also, that denotes its size, right. So basically I iterate till n, that is the size of the array. But suppose instead of n, if I am putting there n by 2, so that means, right, that means I will run till n by 2 only, right? I am passing n by 2 only, right? So basically, how we are figuring out that we will run the complete array, it depends on basically what pointer I am passing, what parameter I am passing, right? So basically, here, suppose I am calling a function that is merge sort, okay, right? If I am passing an array, so the whole array will be considered. But if I am passing some pointers, right? So I will pass some pointer low and high, where low represents this low and where high represents this high. So why I'm passing? Basically, low and high is telling your array is starting from low point and it is running till high point, right? So this pointers will be considered for my array, right? And now what I will do inside this function, I will again call the same function. I will divide them. How I will divide it? I won't divide it completely, right? Like I will divide in a hypothetical way. So basically, I will start from array with a low point, and what will be my mid? So mid will be basically my low plus high by 2, right? So if there is an odd, I will take till mid elements, right? And in the next one, I will simply call merge sort, okay, with the array, and with from mid plus 1 to high. So basically I'm dividing into low to mid. What is mid? Let's quickly calculate. So low is 0, high is 6. So 0 by 6 by 2, that is 3. So I will start from 0 and I will go till 3. That will be my first part, right? That will be my first part. And mid plus 1 to high. So mid plus 1 is 4. To high, that is 6, right? So that will be my second part. So here I have passed 0 to 6 pointer, but I have further divided into 0 to 3 pointer, and this is now 4 to 6 pointer. Once I have both divided both the arrays, right? Here I have divided both the arrays. Again, this will work, right? Because I'm calling these two functions again and again, right? This will call, right? Once left is done, once right is done, then what I will do? I will merge it. Okay. So I will merge it. How I will merge it? I will simply put array and my low pointer and mid pointer, and I will call this high function, right? So these are the three things that we are going to do. Only these are the three things, right? And now the only part is left, that is your base condition. I'm removing this one so that there is no confusion. Now only the base condition we need to execute, right? So when you are dividing, right, when you are dividing, so here you have array values from 0 to 6. Now you have 0 to 4, right? Now you have 0 to 1, and now you have 0 1, right? This is a single element. So when you reach to here, your low pointer will also point to 0 and your high pointer will also point to 0, right? Same index. So can I say we can stop it here because we have the single element, right? Here also my low pointer will point to this 1, high pointer will also point to the 1. So whenever my two pointers are getting equal, I will stop them, right? So whenever, if, right, the base condition will be whenever my low is equal or greater, I'm just taking the worst cases. If suppose if it is greater or high, although it will not, so what I will do, I will simply return it. I will say don't further divide it. Don't further divide it. That's the last divide you have done. Okay, don't further divide it. So whenever low is equals to high or greater than high, I will simply stop it there and that's done, right? That's done. That's the simple code of your merge sort. That's the pseudo code. Okay, it's done, right? This is what merge sort is. Okay, 4 lines of code. Now what we will do, we will simply check what is how to write this merge function and merge sort is done, right? This is basically your merge sort code is, right? Simply one again you are calling the same function again and then we will check the merge sort. So now let's quickly check the merge function alone, right? Basically when we have low pointer, mid pointer, high pointer, how we can merge it. Exactly it is going to be the same as we have discussed, but let's see. Okay, now let's quickly check the code pseudo code of the merge. So basically what we will have one merge function. Okay, inside this merge function we will call with the array, we'll call then low, then our mid and then our high. Okay, so what I will do, okay, I will create two arrays, right? One will be array 1, that will be basically copy, you can say your copy of the array, right? So that will be a copy of your array that will have from low to mid, right? Basically this copy I can say, suppose one make copy function or something where I will simply put all the elements from low to mid. Okay, so let's suppose we'll say copy and I will call array low to mid. Okay, then I will have ARR of 2, that is array 2, and again make copy and that have elements from ARR mid plus 1 to high. Okay, these will these will be the two arrays, right? Array 1 and array 2. Let me take this one as well, right? So like here, let's take the complete array and if I write this, just give me a second. So basically I will create two copies here, right? So one will be array 1 where we have all the four elements, right? Like 8, 5, 8 and 9, right? From ARR, like ARR of is this is low, I guess, yes. Low to mid, right? So you can see here, this was pointing to low, not this one. This was pointing to low and this is pointing to high. And here you can see which is my mid element 0, 1, 2, 3, 4, 5 and 6. This is my mid, right? So I have created this as an array 1, right? And similarly array 2 will have the elements from mid plus 1 to high. So it will have 9, sorry, 0, 4 and 2. That is of 3 elements, right? Not the 4. Okay, remove this one. We'll have 0, 4, 2. Now I have created two arrays. Now I will take two pointers, right? So I can take one I equals to 0 and one pointer here that is j equals to 0, right? Both the pointers I is equals to 0, j equals to 0, and one pointer I can take k. Okay. Now that k will be at the low pointer, right? Because suppose like here you are starting from here, but suppose if there is a smaller part, right? So that means you are at here. Suppose if a function that has a value from mid to high, right? That is calling. So k will always at low point. And this k pointer will be a reference to the actual array, right? This will traverse to an actual array. Okay. While other pointers will run to the array that we have created, right? So basically I have while loop where my I pointer should be less than equals to, I will say only less than, that is ARR of 1 dot length. Okay, and j pointer will be less than AR of array 2 dot length. Okay, basically this the limit for I is this one and j, the limit for j is this one, right? What I will do inside this one, okay, so let me, this will going to be a bit of big. So what I will do here, basically if I check if AR of 1 of I is lesser than, right? So let's take both the cases, lesser than or equals to, because either we need to take one case. So I will take in the lesser than or equals to, what I will do, AR of 2j. So in that case, what I will do, I will simply say Now this is my actual array. Array of k will be array 1 of I, right? And I will move both the pointers. So basically I will move my I plus plus and I will move my k pointer k plus plus, right? Or also if you want, you can move this k at the end. That is also possible, right? So else condition here, suppose 2 is the smaller, right? Array 2 is smaller. So in that case, what I will do, I will simply say AR of k will be equals to array 2j, array 2j, and I will move j pointer j plus plus, right? After this loop, right? This while loop is end, right? And like here in the last, I can say simply, right? Because either you can put here, let's put here and as well, or you can simply put after this if and else, right? That is also fine. And this is your while loop done. But after this, what you will do, because there is a possibility that so your j is reached to the end, but there are still some elements in the I that are left. So you will create one while loop, okay, where you will simply check if I is lesser than array 1 dot length. Simply put all the elements of I. So you will simply say AR of k will be equals to array 1 I, and you will do I plus plus, you will do k plus plus, right? Similarly, suppose there are some elements that are left in j, okay? So if j is less than array 2 dot length, then what you will do, you will simply say AR of k equals to array 2j, array 2j, this is 2j, and that will be j plus plus and k plus plus, and that's it. In the last you will return it. So basically you have created, you are changing your array, right? So see what I am doing, I have created two sets 8589 and 0402, and now I am doing, I am simply change, I am taking the lowest, so I am taking lowest and I am doing a change in my actual array 0 here. Then I am taking the lowest, right? Is j, is I is lowest or j is lowest? J is lowest. Then I will again check is I or j. So j is lowest. Then I am doing a change in my actual array. So that's why I am starting from the low point, because that is for my actual array, and I am reaching, right? I will reach till basically till they fill. Okay. So that will be your merge function, right? And this will be your merge sort function, right? Now let's see basically how this code will work, right? We have written this code, how this code will work. So now merge function is clear completely, so I'm not going to do a dry run of this. Basically how this is working, this is exactly working as the same, right? So here you can see your I is pointing to 0, 0, 1, 2, 3. J is pointing to 0. Okay. I will simply check is array 1 of I is lesser than equals to array 2 of j. Yes, it is lesser. I will simply first put array k, then array 1. I will simply first put array 1 of I to array k, and I will move I plus plus and k plus. Whatever the dry run that we have done, exactly the same. Okay. So now let's move. Okay. So let me quickly copy this one and paste it here. And now let's do some function calling so that we can understand how this will work. Okay, so let me quickly create a recursion stack. And now let's see the how the dry run will work here. So I will first call one function, like let me put this at the top. Okay, I will first call the function merge sort, right? So in merge sort, I will pass array and I will pass my low pointer and my high pointer. So that is my high, that is my low. So I will pass 0 and 6, right? So here I am simply writing ms with 0 comma 6. Okay, let me increase its size. It's a bit small. Yes, call ms, basically merge sort here, merge sort, that will call 0 comma 6, right? Now after this, I will check is my low pointer. So this is my low pointer. This is my high pointer. Is low is less than greater than equals to high? No, it's not. So then I will call one next function again merge sort with low and mid. What will be the mid here? 0 plus 6 by 2, that is 3, right? So I will call one more function, that is ms with the array with 0 comma 3, right? So I will call ms with 0 comma 3, right? Again this function will come, right? Again I will execute. Let me remove all this stuff. Again I will execute. That's merge. Okay. Again when I will execute this one, right, I will check is my low pointer is greater than equals to high. So low pointer is 0, high pointer is 3. Still it is lesser than, right? It is not equal. So I will call this function merge sort again with low and mid. What is the mid? 0 and 3. What will be my new mid? 0 plus 3 by 2, that will be 1 by 2. So can I say 1? So that will be ms, and I will pass array and 0 to 1. So it will be ms 0 to 1. Okay, so I will take this one on this much only, my array, right? So you can see here in the first I was taking this much array, right? Now I am taking 0 to 1. Okay, again I will execute this one. Is my low is greater than equals to high? No, still it is not. So again I will call the same function merge sort with low and mid. So what will the mid of 0 plus 1 by 2? That will be 0 only. So I will call ms array with 0 comma 0. So I will call this merge sort function 0 comma 0. Now we have reached when we have low is equal to high, right? So I will return it. So basically what I will do after calling this function, I will simply return it, right? And so can I say my this function is done? Basically this was merge sort. Can I say my this function is done, right? So I will execute the next one, and the next one is mid plus 1 to high, right? So the next one is mid plus 1. So ms array, right, mid plus 1. What was mid? Mid was 1. So 1 plus 1, or here you can see, so mid of 0 plus 1 by 2 will be 0. So array of 0 comma till 1, right? So this will be from mid plus 1. So mid was 0. So it will be 1, right? It will be 1 to 1, not 0 comma 1. So this function was done, right? ms 0 comma 0. So can I simply remove from the recursion stack, right? Okay, it got returned to this function, right? Then we have called ms 1 comma 1. Okay, that means we are at this 8, right? So that is also done. This is also done, right? Because here low is equals to high, so this will also return. So this will also return, right? So can I simply remove from recursion stack? So I will remove this one. Okay, now both the functions are done, right? I have called this one, right? This got returned. I have called this one. This got also returned. Now what I will do, I will simply merge low, mid and high. So what I will do, I will simply return the low, mid and high. Basically this function will execute merge low, mid and high. So basically here 0 to 1, I will sort this. Basically I will sort 8 and 5 to 5 and 8, and I will return it, right? So I will simply sort it and I will return it. So can I say my this function ms array 0 to 1, that is also done. So this is also done now, right? So this is 0 to 1 is also done. If we can create one example here, so that will be good. So you can understand it like this, like from 0 to 6, so there was a complete array, right? So this was the complete array. Now from 0 to 3, so we have elements in my array, that is from 8, 5, 8, 9, right? Then when I am calling 0 to 1, that means I have two elements, that is 8 to 5. Okay, when I am calling this, then I have only 8, and when I am calling this, then I have only 5, right? And when I am returning this after merge, right, it will be 5 comma 8. Okay, now when I will return this, but I have just called this function, I have completed this function 0 comma 1, then I will call this mid plus 1 and high, right? So I have called this one 0 comma 1. I will call the next function, that will be basically this one. What will the mid? 0 plus 1, 0, and I will call basically here the mid was 1, right? So that's why it was 1. It was 1. Then what I will do, I will call ms with array, and that will be 2 to 3, right? So it will be ms from 2 to 3, right? This will execute first, and again it will so on calculate ms 2 comma 2, then it will call ms 3 comma 3, right? Basically it will take the single elements here as well, right? So if I'm calling array 2 comma 3, so that means I am calling 8 and 9, right? So this will again, it will become 8, this will again become 9, and when I will return it, when I will simply return it, right, it will be 8 comma 9 itself only, right? So now my AR of 2 3 is also done, MS 2 3 is also done, right? After this calling, okay, we have 5 8 sorted, we have 8 9 sorted. What I will do, I will execute merge. I will execute this merge function, and once I have executed this merge function, I will return the sorted array. So I will return the sorted array, that will be 5 8 8 9, right? I will return this sorted array merge function, and basically 0 comma 6 we have called it here. I will return this one, but this will call ms. So I can say 0 3 is done, right? Now the same thing will happen to ms array from, it was 0 to 3, right? The next thing will call from 4 to 6, right? And same tree will happen, right? 4 to 6, again we will further divide 4 to 6 to 4 to 5, and 6 only, then 4 to 5 will divide to 4 and 4, and same thing will happen, right? So I'm not creating for this one, but this is how your code will works, right? This is how it will form the recursion, and this is how your code will works. Okay, again that's a recursion. This function call, then first I will execute this one function call, then this function call, and then we will have merge. Okay, and if we can check with this example that we have discussed here, right, this one 13247, you can simply check this is the exactly same code that we have written here. Let me just shrink it so that we will have some space here. Okay, so here you can see basically I have created one array 1, so this is my array 1, right, from the actual array. Suppose there was one actual array, we have then array 2, this is my array 2, and both are sorted. Then I am taking I pointer, I will start from here. Then I am taking j pointer, j will start from here, right? And while I is less than array dot length, so I till I is less than array dot length and j is less than array dot length, so j pointer is here. I will simply check if array 1 of I, if 1 is less than or equals to 2, right, array 2 of j, right, if it is less than, I will simply fill it here. Array k will be filled by array 1 of I, and I will simply move my I pointer, and I will simply move my k pointer, right? Similarly, in else case, if suppose jth element is lesser, I will first fill with j, and I will move j pointer and k pointer. But suppose in the last, if there are some I elements that is left and some j element is left, so what I will do, I will simply put I k elements, and I will simply move my I pointer and j pointer. Yeah. So yeah, that's all for the this approach. Okay, this is how we can simply solve a problem by using merge sort. Now let's quickly talk about the time complexities. So now let's talk about time complexities. So what will be the time complexity of this approach? Okay. So see, first of all, we have n elements, right? We divided into n by 2 and n by 2, right? Then we further divided into n by 2, right? So it will be n by 4 and n by 4. Then I will further divide it into n by 2, that will be n by 8 and n by 8, right? So I am dividing in like this, n by 8 and n by 8. So what will the time complexity of when you are dividing it, right? Simply dividing it, and that is what your merge is doing, right? So basically suppose you have 16, right? You have 16, you have divided into 8, then you have divided into 4, then you have divided into 2, right? And to this one, right, how many iterations you have needed, right? So 1 2 3 4, you have reached to 2 by simply 4 steps, by 4 steps. So basically what is the time complexity here? It will be log 16 of base 2, right? And what is this 16? Basically 16 is 2 power 4, and if I remove it, it will be 4 basically, right? So what will the time complexity here? The basically dividing will take log n times. It will be take log n times, right? So when you are dividing it, n into n by 2, n by 2 to n by 4, n by 4 to n by 8, it will take log n times. Now when you are dividing it, when you are dividing this one, right, basically this will divide, right, both are dividing the same way. Okay, if you can you can say like why, so why we are, you are not considering this part, right? This will also take the same iterations, right? So here when I am taking this as a same, right? Both are going to take same iterations, right? So eventually it will be log n only. Okay, so here you can see basically it's not that create a difference. Similarly, it will be same, like same of a log n only, right? N to n by 2 and n by 2 to n by 4 and to n by 8, right? Now when we are merging it, when I am merging it, so you can see, right? When I am merging it, I am iterating till the size of the array. I am iterating till the size of the array. So this, the worst case can be, right, you are iterating to the complete size, right? Or not in the worst case, on all the cases, right? When we have elements, right? I am taking one k pointer, so k pointer will reach to the end. So here I am taking n iterations. When I'm merging, I am taking n iterations, right? And this will happen on each set. When you will perform, this will happen here, this will happen here on each set. So the total time complexity will be n log n, right? Basically log n, when basically when you divide it, if you know the binary search, right, lecture, where I have discussed, when the time complexity of binary search is log n, because we basically s- uh, bisect the search space, right? So I'm bisecting the search space from n to n by 2, then n by 2 to n by 4, and so on, right? So dividing will take log n times, and in each divide I am doing the iterations, right? If I'm doing the array iterations completely, that will be n. So the time complexity will be nearly big O of n log n, right? So this will be the time complexity. And what about the space? Are we taking any extra space here? So yes, here we are creating arrays. So I am creating array 1 and array 2. And the extreme cases, if I am taking, so it will be start from low and it will go till high. So I am creating an array that is of size of from low to high. So here the time complexity for this one, space complexity for this will be big O of n when you are creating an extra array, right? So this is for extra array that we are creating. Okay, and the space complexity will depends on the recursion stack, right? So number of steps that you are taking here, right? 1 2 3 4, right? So basically this recursion stack will also take some space. So it will be log n, basically log small n again, if I'm using everywhere. So small n, because if you are simply taking the root, right? So this is one function call, then second function call, then third function call, and fourth function call, right? So again, number of function calls are depending on the basic, like how you are, what is the limit, like from here to here, your tree root, if you know your binary tree, how to create trees, right? So number of function calls are directly proportional to basically how you are calling it, n to n by 2 to n by 4 and n by 8, right? So these function calls, if you can see how I have called it 0 to 6, and next function was 0 to 3, then 0 to 1. So number of function calls are also 4 here, that is log n. So this is log n, which is of stack memory, recursion stack memory. Okay, so this is our recursion stack memory. This is our extra array that we have used, big O of n, right? And yeah, that will be the time and space complexity of this approach. I hope you got it, how this code will work, right? The complete time complexity and space complexity. Okay, and in the next video I will quickly tell you what will the code of it. So in the next video I will complete the code, basically how you can write the actual code of this algorithm, right? And that's all for this merge sort. Okay, so that's all for this video. Okay, in the next video we will talk about the code implementation. Till then, see you, we'll see you in the next video.